Hi, I'm Brady Kiranakira, and I will be leading you through the Saturated Buffer project for Ag Innovators. Let's go over what you will need for the Saturated Buffer project. First, you'll need a half cup of garden soil, which will be the soil in this project. Next, you'll need 3 clear cups, which will be the field with soil and subsurface groundwater. Next, you'll need a pinch of grape Kool-Aid, which will act as the nitrates in the water from fertilizer in the field. Next, you'll need 1 coffee filter to be part of the model to hold the soil in and let the water pass through. Next, you'll need a 3/4 cup of water. This will represent the water after a rain event. Also, you will need 3 medium binder clips to hold the coffee filter. Finally, you'll need 1 permanent marker. This will be used to record your data. The first step to preparing your cup would be to put the coffee filter on top and then holding it in place with binder clips. Next, you will place your soil on top of the coffee filter in the cup. And now to prepare the rainwater with fertilizer. First, take a cup and Kool-Aid and pour just a pinch into it. Next, take 3/4 cup of water and pour it into the cup. Pour half of your water into the other cup. Then take your marker and mark the placement of the water in your cup. Now let's figure out how saturation buffer works. Let's pour half of the purple solution slowly over the soil, which is over the coffee filter, which is attached to the cup. The soil in a coffee filter represents a saturated buffer, an area next to a field where water drains and is collected. Pouring the liquid over the soil represents travel from the field traveling in the tile and draining into the tile's unsaturated buffer. What change do you notice in the saturated buffer? Mark the water line on your cup again. Wait a minute and then pour the other half. What did you notice about the liquid as it passed through the wet saturated buffer? Carefully unclasp your binder clips and then put your coffee filter and dirt into the trash. Compare the liquid in the cups. What happened to the water? Why might you expect less water to come out after the saturated buffer? How does the saturated buffer remove nitrogen from the water?